Two and a Half Admins, episode 101. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. And before we get started, your customary blog post plug, Allan, is contributing to open source beyond software development.
Yeah, so if you've ever wondered about contributing to open source and you're not a programmer, we've broken down a bunch of the different ways that open source projects need people beyond just the developers.
Right, well, link in the show notes as usual. Jim and Allan, both of you hassled me to talk about GitHub Copilot. I've covered this extensively in other shows, so let's hear what you two have to say about it. Who wants to go first?
I'll go first. So the first thing that I will say, if you haven't yet listened to the Linux Downtime episode where Martin, Joe, and Hayden all talk about Copilot, you absolutely should. Hayden in particular brings a lot of incredibly valuable insights to the discussion. One of the big ones that he addresses is a question that, has bothered me about all the whinging about Copilot since day one, which is the idea that, oh no, it might put snippets of my GPL code in proprietary stuff, yada, yada, yada. And I was like, okay, but how large are they? And, at what point can you not say, oh, this is my super unique code? Like, for loop equals 1, loop less than 10, loop plus plus. Like, you don't really get to copyright that, It's like saying somebody used the same word you did and therefore they violated your copyright. That's not how it works. Hayden goes over that. He calls it, I believe, incidental inclusion.
Yeah.
Basically, it boils down to that's not really a big problem. The one thing that I didn't feel like got addressed in that episode, and it really bothered me. Another common complaint is this idea that, well, okay, whether it's about the code snippets or not, the algorithm is learning from our GPL code, and then it is being used to make GitHub and Microsoft money when people pay for subscriptions to it, and the GPL folks don't get a cut of that, yada, yada, yada. This really bothers me when I hear people say that, because I lived and worked through at least 10 and probably more like 20 years of FOSS haters bringing out all this fear, uncertainty, and doubt, saying, oh, if you're a professional developer, you must not ever so much as look at the code of any GPL program because it's viral and it will taint you and you can never be sure that yada, 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 and you won't be able to work as a programmer, which was always complete bullshit then, and it's complete bullshit now. The proper model for talking about this AI learning from open source code is not what it's being made out to be. It's basically the same thing going on as when a larval form human programmer reads your source code and learns how to program by seeing what you've done. And if you give into this idea to say, oh, you can't train an algorithm on source code because it's derived value from it that it didn't pay for or whatever, like you have really just done the FOSS haters' job for them at that point. You're making the exact same argument that they did, that GPL code is viral and tainted and you must never touch it or you'll never be able to make money again, and it's crap.
Some of the biggest problem is that the law on a bunch of this stuff is unclear. For a while, we thought that just the header files that define the API of something were okay. But then the Google Oracle lawsuit happened, and then it was okay, and then it wasn't okay, and then it was okay again, and then it wasn't. And it's very unclear on how much of stuff is obvious or required for compatibility, and then where the line is between what is permissible and what is not.
And Copilot is never going to implement an API.
Right.
Like that's not a thing that it does. You can get a full, simple iterator out of it. You can start out with a code comment saying, I want to iterate through all the variables in an array, and it will suggest, a for loop that does exactly that. You don't even get to your computer science courses in university before you learn how to do this stuff. This is like something that you learn in summer camp as a kid learning to computer real good. It's not something to get worked up over.
Even the question of, how much can you change in a source code file before it makes sense to add your name to the list of copyrights on it. Like even if you're just thinking about open source, a GPL file or whatever, and you're legitimately doing the programming yourself, usually there's a line where a certain amount of changes just aren't enough for you to really claim copyright on. And if what Copilot gives out to people is that small, then it's kind of the same thing. It's like you're not ending up having to credit the person who wrote the original stuff, because you're not really infringing on their copyright because you're using such a small snippet that it's permissible or, it's considered de minimis or whatever. But there's no clear definition on where that line is, where You've copied enough that suddenly it's similar enough that you need to credit the person that this was copied from, or where you've added enough to it that it's become not just the original thing. So much of that is a judgment call, and even that judgment is just based on how the community feels is about right, because so much of the law on this stuff has been untested, and especially around the GPL and so on. We don't think we want it to be tested because if it were to go the wrong way, it could upset the entire ecosystem.
I want to make it clear. I'm not going the disgraced Google engineer route and saying, oh, Copilot is like alive and we have to respect it. No, not that. When I say that you should think of it as human, it's because that's a useful model. I don't think there are many cases in which you can't ask yourself, if a human programmer did exactly what Copilot is doing, would I be upset about it? And not have a good sense there. It's a very good model to evaluate these things with. And as an open source developer who generally chooses the GPL3 myself, it's pretty easy to say, all right, let's say that somebody reads the source code to Sanoid, my most popular project, and maybe they learn how to use Perl hashes, and iterate usefully through a complex structure by reading the source code to Sanoid. Do they get to then go and write a proprietary code with a similar iterator iterating through a hash that does something completely different? And the answer is an unqualified, resounding, God, yes, please do that. Are you kidding me? Now, the story would become different if Copilot you could just say, open up a comment block that says, I want to maintain snapshots on a ZFS system. And it's like, and farts out, something that's 90% Sanoid. Well, that's different. But that is so far from what it actually does as to be completely laughable. Like I said, think 5 or 6 lines entirely encapsulated inside a pair of curly brackets because it's for a for or a while loop. And you've got a pretty good idea of the kinds of things that Copilot will prompt you with. It's just not something that you should be upset about a human doing, having learned it from your code, and you shouldn't be upset about the AI algorithm doing it because it saw your code either.
Yeah, and I think some of the confusion around this comes from misunderstanding the difference between copyright and patent. The kind of the FUD around, oh, you don't even want to look at the other version is mostly around patented stuff. If you're going to do a clean room implementation that's not tainted by the way the other person did it, you don't want to read that code. But that's really about patents that are about process. Whereas copyright is just this specific thing is copyrighted and you'd have to basically use large chunks of it before fair use is not the right word. But I guess another way to think of it is like some TV show reuses a bit of an idea from some other TV show. That's not stealing their copyright, right? We're not airing the whole episode of the original show. We're just taking the premise of that and doing our own story based on it.
Which is still giving Copilot too much credit for how much it's actually offering. I would use a literary analogy to what Allan was saying. It's basically like saying just because Arthur Conan Doyle wrote the Sherlock Holmes stories doesn't mean that you can't write your own detective novels. But Copilot's not writing detective novels either. It's more like saying because Sherlock Holmes went to the bathroom once, you can't have your character go to the bathroom in your book. And no, you can. It's fine.
I can't believe we missed the chance to talk about Star Trek and the Orville here.
I was actually just thinking that maybe that was a bad example because Star Trek got sued for doing a Sherlock Holmes episode.
Did they?
Yeah. That's why the Moriarty character didn't come back until season 7 of TNG because it took them that long to work out the rights with the Conan Doyle estate.
But they used the actual freaking character.
Yeah.
They didn't get sued because they had a detective episode. And they certainly didn't get sued because the detective went to the bathroom once.
Yeah, and it's why Seth MacFarlane hasn't been sued for the Orville, even though it's blatantly just TNG. Because it's the same idea, but it's different enough, right?
And until Strange New Worlds, it was the closest thing to Star Trek that's come out in a while.
Yeah, exactly. I am quite surprised, Jim, that you are so easy on Copilot because you are the free software guy, the GPL guy.
Yeah, but Copilot isn't writing software. It's just a slightly smarter auto-recommend. Like my code editor has had auto-completion where it tells me the names of the parameters for the function and so on forever. And I will totally admit the number of times I've had to think too long to remember the order of the things in the for loop or which way around I should make the greater than bracket face. And having Copilot do that seems useful.
Exactly. And you're right, Joe. Yeah, I'm the free software guy. I'm the GPL guy. I'm the guy who will wax lyrical about why I think the choice in license advanced Linux over, FreeBSD or what have you. But the thing is, like, I'm that guy because it means something, not because it's an empty religion I'm just trying to adhere to all the tenets of, you know? You stop and think about what the GPL was actually created for, and it was created to keep the rights of users strong, to allow you to use and develop software. That's what the GPL is for. The GPL is for keeping companies from locking you out of the ability to create and modify and maintain your own software. And Copilot isn't screwing up anybody's ability to do that. Some evil giant corporation isn't going to be able to replace a popular open source project because Copilot barfed out a for loop. It's just, no.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. I saw a very interesting story recently about Intel's 12th gen CPUs and the bar exam. That's the exam you have to take in the US to become a lawyer. And you can't take the bar exam on a machine with a 12th gen CPU. And it turns out that that is because of the E cores, the efficiency cores. Because the software that you need to run to take the exam sees the different types of cores, gets confused, and assumes you're using a virtual machine, which you're not allowed to use if you want to take this exam.
And this is the part where I'm the free software guy again, and I say, DRM is evil, it screws up, it's badly coded, and it just gets in the freaking way. Because that's really what this boils down to. You know, the folks administering the exam have gotten it in their heads that there's some amazing way to cheat if you're using a virtual machine for some reason. Not entirely sure why.
Well, I think in particular, this software makes sure you're not opening a web browser or something to look up answers on the machine. And if you're running it in a VM, it can't see outside the VM.
Which is hilariously misguided because there's so many other ways around that problem, ranging from different devices to do your browsing in the VM, not the bar exam in the VM. I mean, just... it's endless. But because somebody got it in their head that, you know, oh, this is a way that people might cheat, all of a sudden it doesn't work on literally the most common processor.
What I found surprising is that you're taking the exam on your own machine instead of their machine, because it seems to me the only way they could ever be sure you're not cheating is at least they control the machine, not you.
Well, I'm assuming this is like remote COVID, that sort of thing.
Right.
Because I saw some comments on the Ars Technica article that we will link to that said that people had taken the exam in person in the past and they'd taken Advil with them and they weren't allowed to take the Advil into the room.
Because there's writing on the bottle.
No, writing on the pills.
Yeah, that too. One wonders if they get upset about if you still got the tag on the inside of your T-shirt.
Yeah.
But yeah, once you open the door to taking the exam remotely, where it's not proctored by a human in person, all this is just stuff and nonsense because there's absolutely nothing keeping that same person from having a laptop open right next to their desktop computer and doing all their browsing to look up the stuff there.
Well, except that you usually have to have a webcam and like wave it around and show what's in the room and stuff. But with sleight of hand and hiding stuff, there are ways around that if you're crafty enough.
Yeah. But anyway, the important thing is the way this works is it looks for detecting the AVX instructions, which the E-cores don't have. Although I assume this could cause people the same problem if you had like one of the older like Atom processors, if you had something like a netbook. I don't know that they make many things like that anymore. But if you had a really low-end processor, they often don't have this either. And also, some hypervisors can actually pass through those instructions now as well. Mm-hmm. So it's not actually a good check for whether it's a VM or not.
Again, DRM is bad. It's never thought all the way through. It's almost always poorly coded. This is what you get.
Yeah, it feels like you could structure the exam in a way that it wouldn't matter if someone was cheating. Like, there's a way to find out if a person knows what they're supposed to know and whether they're just quickly Googling facts.
Yes, like there's a whole science that goes into designing these exams to ferret out that kind of thing. Like, I remember when they were designing the BSD certification exam, a lot of the money went to paying for the psychometrician that does this bit of it and designing the test so that half the people that take this test will fail it. And so I'm like making it that specific versus, some of the multiple choice tests I took in college that were just written by the professor. And it's like, yeah, it'd be pretty hard to fail this exam.
I think it's also worth pointing out that practicing law, that's one of the few professions that I would put right up there with IT in terms of there's too much for any one person to keep on top of all the time, and you have to be able to do accurate research rapidly to succeed in the field. It's an enormous component of it, and you cannot expect somebody to go out and be a successful lawyer based on nothing but what they've got off the top of their head, So if you want to make sure that somebody has a good grasp of the topic, a time limit is all you really need. Like, if it takes you too long to look up the answers, you will fail because you don't have that much time to take the test. If you are capable of hitting Google and coming up with complex answers to legal questions rapidly and reliably enough to get under the time limit of the test, well, screw it. You're good enough at that to go be a lawyer.
Yeah, find the relevant case law, the relevant precedents and all the rest of it. And I would push back on what you said, Jim. I think that most professions are like this these days. I think that the world has become so complex that I almost can't think of a profession where you don't need to stay on top of things and have this ability to rapidly find out new stuff.
It's true that to be at the top of any profession, you need to be able to do that. There are a lot of professions where you can survive without that. But in IT or law, if you try to work on nothing other than what you've already learned, you end up being, well, that developer from the last episode that all he does is Silverlight and he refuses to do anything else. Yeah. I mean, you're that guy in like a couple years if you stop learning in IT.
Mm.
When I interview folks for IT positions, I am 100% fine with them searching for things. I don't care what it is. I'm not thrown off by I don't know that. I like hearing that. Okay, how will you find out? Walk me through or show me how you're going to get the answer to that question. And if they do a good job of it, I'm like, this is an excellent candidate. And I am more likely to want to hire that person based on seeing them solve a problem they didn't know the answer to in a reasonable amount of time and accurately than I would have been if they just rattled off a thing they memorized. Because if that's how they solve problems, is just rattle off a thing they memorize, they're going to be bloody useless for 90% of what they need to do on a daily basis.
Yeah, any new problem is going to be stumped.
And they're all new problems.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support to learn more about it. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Allan or your feedback, you can email show@2.5admins.com. So Michael writes, I'm having a debate with my colleagues regarding VM database consistency. My understanding is a VM with a memory dump snapshot, application consistent snapshot, is safe for databases. Their theory is an atomic, disk-only, crash-consistent snapshot is better because a memory snapshot may catch the database in between transactions where a crash-consistent one would not. Curious of your opinion. Thanks.
Okay, so first of all, let's talk about consistency because this is something that I don't see many people get right all the way down the stack. So when we started talking about consistency in the file system, the first approach to that is file system journaling, or in the case of ZFS, you have the full copy on write mechanism. And in either case, the reasoning behind this is that if you get a power loss or a kernel panic or some other complete interruption right in the middle of something, you won't have a corrupt file system at the end. Because when you reboot the system, it will see that you've got stuff in the journal which hadn't been finished writing the journal. And so it just doesn't apply the stuff in the journal to the active file system. Because the way it works is you write your stuff in the journal, and then once it's complete in the journal, you atomically move that out into the production file system. And you could quibble with some of the exact words that I'm using here, but this is basically what we're talking about. You do things that take a long amount of time in a scratch area of the file system, and then you only make them production in a single atomic operation. And atomic means that you can't split that up. So you can catch half of a file system transaction in the journal, but you can't catch it half committed to disk because the actual commit is an atomic operation.
Yeah, it either happened or it didn't happen.
Exactly. So if you have a power loss, you can absolutely lose data. On a journaling file system, you can absolutely have a corrupt file. What you can't have is a corrupt file system because that metadata only gets committed atomically after it's been written out into the journal. So that means that you don't, have a power loss and turn your system back on and it won't boot because the file system is hosed. However, you may absolutely have lost the file that you were writing to at the moment in time that happened. So now we move into databases. Databases also should be journaling these days. Now, not all database storage engines aren't. The big one that leaps to mind is folks that are still using MySQL with the old MyISOM database storage engine. That is not journaling. And if you interrupt it in the middle of writing into the database, you are very likely to have a completely hosed database that you'll have to try to, surgically repair and may not even be able to afterwards. It sucks. So don't use MyISOM. Use, for MySQL, InnoDB. InnoDB is journaling, and it works just like the file system. You absolutely can lose data. What you can't do is have the entire table or database itself be corrupt because you wrote half of something and not the rest of it. Now, what you can still be, despite having a journaling file system and a journaling database storage engine, you can be application inconsistent. So what that means is maybe you have two update queries you need to write in a row. Maybe one of those updates a row in one table and another updates a row in a linked table. And if you only execute one of those update queries, you can end up with a dead link to something that doesn't exist in another. You can screw up your application in all sorts of ways. Imagine, for example, that you created rows in an invoice, but you hadn't created the actual invoice yet. And so now you've got just like orphaned line items sitting out there. This is one example of application inconsistency. To fix that, you build your database application so that if it needs both of those update queries to run before that operation is complete, you encapsulate those in a transaction. And the transaction works basically just like the journal does. If you've only completed half of your transaction and the database crashes, when you bring it back up, it rolls back the partial transaction. So the net effect is basically like your power loss or whatever kind of crash you had didn't happen when it really happened. It happened, say, 150 milliseconds earlier when you weren't in the middle of a transaction. You were cleanly in between. So you have no corruption now at the file system level, at the overall database level, or at the application level. Everything is consistent. It's like you shut the machine down at that point in time, 150 milliseconds, 2 seconds, whatever the last clean state was prior to when the power loss actually occurred. Now, understanding all that, we can move into Michael's actual question about is it better to snapshot a VM with full system state, which is actually more than just the memory. You also have to save the state of the CPU registers and what have you to make sure that everything's consistent when you bring it back up. This is the equivalent of like hibernating a desktop machine. When it comes back up, it puts you exactly back where you were. Absolutely no data is lost. It just went to sleep for that amount of time. That's fine. The other option was a disk-only snapshot, so that's going to be crash consistent. Now we're back to our power loss scenario. It's just like you pulled the plug in the middle of something happening. Now, assuming that your file system is crash safe, your database engine is crash safe, and your application has properly encapsulated everything in transactions that needs to be transactional, either one of those two is perfectly safe and you won't have any corruption on restoring the snapshot or after a crash or what have you. However, it can still be important to understand the difference for backup and restoration reasons, because if you've got a disk-only snapshot and it's crash consistent, you take the VM snapshot in the midst of a database transaction, it will obviously roll back that transaction. So your snapshot will effectively have happened a couple of seconds prior at your last clean state. Now, what this means is if you say, well, I know my database was hosed at 12:01 a.m., I can just roll back to my midnight snapshot and know that I won't have whatever thing that I did in my application that hosed everything and I want to undo, and you will be correct. On the other hand, if you're using, this hibernation style snapshot that saves system state and contents of RAM as well as the disk, what will happen then is perhaps you had issued that bad command or update or whatever you want to call it in your application that resulted in something you did not want, and it was only halfway through doing it at midnight. So even though you only knew your database was screwed up, call it 12:01 a.m. and you roll back to your midnight snapshot, if it brings back all the system state and all the contents of RAM, it's going to complete applying that transaction that may have been the transaction that broke your system. So you may discover that your midnight snapshot will no longer undo a problem that didn't actually occur until a few seconds or a minute or whatever after midnight. This is all really, really deep in the weeds. It basically just comes down again to, you want to understand the semantics and you want to understand the implications of either method. But again, assuming that file system, database engine, and application have all been built properly, they will be consistent after recovery in either case. So it just comes down to which way you want to do it.
Yeah. So the big thing with doing transactions is you get the ACID compliance. And the idea is that the database will not tell your application that the transaction was completed until all of it's persisted on disk so that it is crash safe. So if you're doing the memory snapshot, you can get in the weird situation where, like Jim said, it's like hibernating your laptop. But if you've ever hibernated your laptop, when you bring it back up, all your network connections are gone because they timed out because you weren't answering because your computer was asleep. So if an application says, somebody's trying to place an order, here's the order, and then your database dies, it never told the application it was complete. And so you don't end up with two copies of the order because one you thought it went through and it didn't or whatever. So you know for a fact the order didn't finish. But if you are doing the memory snapshot type, if you pause and completely hibernate the VM during the middle of that transaction, the database will try to complete it, but the application that requested it won't be there to find out that it completed. And now that order has went into the system, but the application said, I waited 2 minutes, the database never answered, that your order did not go through. And then, the customer places a second order in a different database or something, and now you have two orders when you didn't mean to.
That's an excellent point, Allan. That was actually a different scenario than I was picturing, because for it to work the way you're talking about, the application has to be on a separate machine than the database, which of course is a thing that happens all the time. I was thinking more in terms of like a web app that's running on a server in a bottle where you've got the application and the server on the same VM. But even then, you can very easily have problems. There are a lot of maintenance update queries that may very well take half an hour to run. And if you interrupt one of those with a crash consistent snapshot, when you roll back to that snapshot, it undoes anything that very long running query would have done. If you restore from a full system state snapshot in the midst of this extremely long running query that's trashing your database, it will just proceed to pick right back up where it left off and finish trashing your database again. So you just have to decide what you want and plan around it properly.
Yeah, in general, basically, you definitely want atomic crash consistent snapshots of the disk. If you can also get the memory, sometimes that's also helpful. Often what I configure mine with is I get the ZFS snapshots to get my atomic crash consistent thing, but I also keep the MySQL binary log so that I can replay as many of the transactions as possible between the last snapshot and the point where it died to, bridge the gap of that 15 minutes between snapshots to maybe make sure I only lose the last couple of transactions. And again, because of the way MySQL works, if it told the application it succeeded, it'll be in that log and crash consistent on disk. And if it didn't, I don't actually want it to complete later anyway.
And keep in mind, if a crash consistent snapshot is not good enough for your application and it winds up being corrupt, your application will also not survive power loss, kernel panics, any number of god-awful, sysadmin type operator errors. Basically, you need to fix your freaking app, and for more reasons than just anything to do with the snapshot.
Yeah, even just running out of disk space can really cause problems for databases.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Allan Jude.
We'll see you next week.